Hello. All right. Do you hear an echo?
There's a slight echo.
A slight echo, huh? There we go. Okay, all better. All right, so welcome to our first meeting. I'm so happy to be here with you. I start with my meetings all muted just because I can hear small background noises in case you're not using your phone. So if like you move your laptop or something, or if you're writing, we can hear everything. So I mute you, but if any moment you want to ask a question or you need to say something, feel free to unmute yourself and ask a question. If you're shy and don't want to propose your question that way, that's okay. On the bottom of your Zoom screen, if you move your mouse around, you'll see a bottom row of icons show up. There's one that's called chat. So I'll have that one open throughout our meeting. So in case you have a question and you don't want to speak your question, you can always propose your question via chat. I'll have that open so I can see what you're asking. I have all of you with your screen off, and that's just to encourage you to be here. I know some professors are really big at having their screen on, but it doesn't matter. I know you're there. I know the communication. We're having that communication, and I'm just happy that you're here. If for some reason well, those of you that aren't here, or in the future, if you can't make one of our Zoom meetings, it's not a problem. I'll post the recording on the page from our module where I talked about us meeting via Zoom. I'll add the meeting there. I'll say best chance, I'll post it tomorrow just because it takes like 15 minutes for Zoom to make it available to me and then like 5 minutes to download and like an hour for it to be available from the download to YouTube. So it's a turnaround time. So best chance tomorrow, but as soon as I post it, I will make an announcement of it. I think that's about it before we begin. So what I'm going to do is I'm going to share my screen. I have another Zoom account with us. I'll share my screen and we'll go through the problems. I sent you the problems as an email, so you knew ahead what we're going to go over. But if you have any other homework questions, you're free to propose them and ask them at the end of our lecture, and I'll be happy to help. At the end of our review, I do want to just go over Canvas basics just to make sure we're all on the same page. I hope we're on the same page since we're in week 4, but it's always good just to make sure that, I don't know, to voice it and let us know that we know how to work Canvas, we know where things are. All right, so let's go ahead and begin. So I'm going to share my screen. And also, I have my, what's it called? My mic through my writing device, my iPad, my tablet, because if I don't, there's a really weird echo that comes from the tablet, plus you can hear all the clicking from me writing. So that's why you hear my face, but there's another screen showing the voice and that there's sound coming. So that's why that is. Okay, so chapter 1 review. Before we begin, I just wanted to begin with expanding a binomial. So how do we go about when we have to have something squared and we want to expand it, we want to multiply it out? So one of the ways we can go about it is we can go ahead and FOIL. So we know that this means 2x minus 6y times 2x minus 6y. It doesn't mean that you square each term. There's a meme that shows that every time we do this, a puppy dies. I'll post it on our Zoom page because it doesn't happen. It's not how it works. Just like how we see, for example, if I see 2 squared, I know that means 2 times 2, which gives me 4. That's how we treat a binomial as well. So one method you can go about it is what is called FOIL. So that means you multiply F is for first, O is for outer, I is for inner, and L is for last. So if we do f, 2x times 2x, that gives me 2x squared. If I multiply O for outer, 2x times negative 6y gives me negative 12xy. And then I for inner, negative 6y times positive 2x, negative 12xy. And then we have L for last. We have negative 6y times negative 6y. A negative times a negative is positive, so plus 36y squared. And then we combine like terms. And we see that, yes, I can combine those middle terms. So I'm left with 2x squared minus 24xy plus 36y squared. And that's how we go about it. Now, I also want to show you that a rule that we can use so that that we don't have to FOIL each time. So these are your formulas. And that is, if I have an A, whatever A may be, for example, our A would be that 2x. And then a minus B, in this case, our B would be that negative 6y. That's being squared. That will equal A squared minus 2 times my A value times my B value plus my B value squared. So in case you don't want to FOIL, there's a formula that'll help us expand that. Now, if it's a plus, our formula is some A value plus my B value being squared. That is A squared plus 2 times my A value times my B value plus B squared. And I just wanted to highlight that because you've been seeing that in your homework where you have that some value squared. Okay. Let's go ahead and continue with these problems. So these problems that I chose from there's some of them, they're the homework problems that you have to do. Other ones are just problems I thought, this one's challenging. It's worth us doing. So for this first one, it's from section 1.1, problem 33. It reads, given the function g of x equals 5 minus x squared, you evaluate g of x minus g of a over x minus a. So I thought this would be worth doing. So to begin, let's find these values. Let's find out what they are. So one of the values we have is g of x. Well, what is g of x? G of x, that's just our function with an x. So 5 minus x squared. That's that. Okay, next I have minus g of a. What is g of a? So it's saying we're taking our function g, and for every x, we're going to write parentheses a. So that we have g of a is 5 minus a squared, which just gives us 5 minus a squared. All right, so I have my g of x and my g of a. Now we can go ahead and use our formula so that we can simplify. Okay, so we have g of x is 5 minus x squared minus g of a, which is 5 minus a squared. Okay, and we want to divide everything by x minus a. Okay, we did the setup. So if this was a question, say like in an exam, this would be, honestly, this would be half credit. This tells me so much. It tells me that you know how to input values into a function, and you know how to take that and apply it to a formula. All right, so now we're left to distribute that negative into my g of a. So that we have 5 minus x squared minus 5 plus a squared, right? Because that negative a times a negative is positive over x minus a. And we see here that we have a 5 minus 5, which gives a 0. And so far what we have is negative x squared plus a squared all over x minus a. Almost done. I think if you got this far in a homework problem, I'm sorry, on a quiz or exam problem, this would be a good 8 points. This tells me you're at a B level, you got it, you're good. The last piece to get that full credit would be you have to catch that this is factorable. Now, factoring is an important and helpful tool if it's something that you need practice on. There are videos on the module from week 1 that are useful, and some videos that are on the Math110 Canvas shell, not module. All right, so how can this factor? So because we have a minus and squares, that factors to be a minus x and a plus x. So you might have to change things over so that the x is in the middle. So what I'm looking at is as a squared minus x squared. And you should recognize that when I have a binomial with a minus in between and 2 terms being squared, I can apply this as a difference of squares. All right, and all that's being divided by x minus a. So I see that, hey, the ones with the minus almost look the same, but the ordering is slightly off. What we can do is we can factor a negative from that first one or from that second one. Let's factor a negative value. And that changes the ordering. So if I factor a negative, let's say a -1, or you can just write a negative, I will have negative a plus x and a plus x over x minus a. And now we see how we have the a with a negative and my x that's positive. They're the same thing. If you want to, you can rearrange that top one. And let's go ahead and do that. So I have negative x minus a and a plus x over x minus a. So now we see, okay, we see it. Those two divide to make 1. They're gone. So my final answer would be negative times a plus x. All right, let me put all that together. So in case you want to screenshot it, feel free to do so. Again, this video will be available to you as a recording afterwards. So I chose this question because it emphasizes that difference quotient that you might recall from college algebra. And that always translates and gets you ready for like that first chapter of calculus. So that's why I make it a big deal here too. Now I like this problem because it highlights a lot of little things. It highlights factoring, it highlights making sure you distribute the negative, all these little things that can easily be little hiccups. All right, let's continue with question 2. (1.2) problem 39. Consider the relationship 3r plus 2t equals 18. A, write a relationship as a function of r equals f of t. B, evaluate f of -3. And C, solve for f of t equals 2. Now, I like this question because I know you know how to do it, but the wording is slightly weird. We had a problem like this in the example, but I don't know. I think it's a good one to do together. All right, so for A, it's asking to write the relationship as a function of r equals f of t. So in other words, it's saying solve for r. So let's go ahead and get r by itself. So we have 3r plus 2t equals 18. Okay, we want to go ahead and get that r by itself. I think it's helpful to highlight it. All right, let's go ahead and get r by itself. So minus 2t to get 0, minus 2t. And we're left with 3r is equal to 18 minus 2t. Last piece, let's get r by itself by dividing by 3. And we're left with r is equal to 18 minus 2t all over 3. Now, that r equals f of t that we see in our question, it's saying that once we solve for r, we need to write in terms of f of t. And that makes sense since our argument is in terms of t. So all we do is replace r with f of t. So final answer is f of t is equal to 18 minus 2t over 3. That satisfies that part A. Part B is saying plug in a negative 3. Okay, now in math, we don't like to say plug in. It's very informal and a lot of people, that's their pet peeve. In math, we say substitute. So we replace our x with a negative 3. Let's go ahead and do that. So we have our function right here that we just found, right? So we say f of negative 3 is equal to 18 minus 2 times negative 3 all over 3. And then we just simplify it out. So I have 18, and then I have negative 2 times negative 3, positive 6 all over 3. 18 plus 6 is 24, divided by 3, that gives us 8. So we can say f of negative 3 is equal to 8. All right. Last part, C. I know these are lengthy. I think you have to do like 2 or 3 of these. Solve for f of t equals 2. So when you're working with that function notation, think of this as your input and this as your output. So it's telling us that this is our answer. We want to find out what t is when our answer is 2. So to set it up, you're going to take our function and set it equal to 2. So that I have 2 is equal to 18t minus, 18 without a t. 18 minus 2t over 3. And now we're doing the opposite thing. Now we're solving for t. But I think that question, the purpose of it is to make you question that function notation. All right, so let's go ahead and solve. So let's multiply both sides by that 3 so that we can get rid of it. 2 times 3 is 6. We're left with 6 is equal to 18 minus 2t. Let's subtract 18 to get 2t by itself. 16 minus 18 is, 6 minus 18 is negative 12, equal negative 2t. Last piece to get t by itself, divided by a negative 2. So we're left with negative 12 divided by negative 2, it's 6. And that's the answer for t. So then we can say that that's our answer, but we can say that f of 6 is equal to 2. So these are very tricky function notation like questions. But I think maybe once we see it or do one together, you're like, okay, I can see where that came from. All right, moving on to the next problem. And at any moment, if you have a question, you can always unmute yourself and stop me. I will happily answer your questions. And there's no such thing as a silly question. I guarantee you that if you have a question, someone else has that exact same question. All right, problem 3. Find the domain and state the domain in interval notation. Without the S notation. All right. So this one is problem 22. I like to assign the odds because you can see the answers on the back of the textbook for the odd problems. But I chose this one because this one's interesting. It's a puzzle. All right. So when we talked about radicals and domain for your lecture, your pre-recorded lecture, we said that when we have a radical, we have to be careful because our only problem is that whatever we have inside, it needs to be positive, right? So it can be greater or equal to 0. But this one is tricky because the denominator cannot be 0. It cannot equal 0. So that one would be strictly greater than. So for our numerator, we're going to take our numerator and we're going to write it as x is greater or is, sorry, x minus 4 is greater or equal to 0. Because it can be 0 and it can be positive, it just can't be negative. Whatever x is, it can't make it so that when I subtract 4, it gives me a negative value. However, in the denominator, we don't write equal to 0 because my denominator cannot be equal to 0. So that one I write it as x minus 6 has to be greater than 0. All right, we have to find our answer for argument, and then I have to find where they both are true because I'm saying this for all of my x values. So it has to be true for both parts, both the numerator and the denominator. All right, let's go ahead and solve. So I add 4, I have x is greater or equal to 4. All right, I add 6, I add 6, get x is greater than 6. Now I need to write my answer as interval notation. Now I don't know about you, but I'm totally a person that understands it, but I need to be very careful because I will make the silliest mistakes. So I need to visually see what's going on. So let me go ahead and graph this because my answer is where they overlap. So I'm working with the numbers 4 and 6. You don't need to make a detailed number line. I just need it for comparison purposes. All right, so I'm looking at 4 and I want the numbers that are greater and equal to 4. So they're greater, but because they're equal to, I will use a closed circle, which will translate to be a bracket. All right, the next one is saying x has to be greater than 6. So greater would go towards the right, but I need to make sure that I use an open circle, which will translate to a parentheses. So I'll write it just for the sake of not making a silly mistake. Okay, but this whole argument is in terms of x. They're the same x for both. So I have to look where it holds true for both. So I want to see where they overlap because that will give me my answer. So I see that they begin to overlap right there, starting at 6. That's my answer. And also the cool thing about writing it as a number line is I have my interval notation done. It's continuing forever towards the positive infinity side. So my answer would be from 6 to infinity. Pardon my ugly infinity sign. Infinity is always is a parenthesis. And because our 6 was an equal to and not equal, sorry, my 6 is a greater than, not a greater than or equal to, we use a parenthesis. And that is our domain in interval notation. Okay, next question. Section 1.2, problem 43. This is a piecewise function. When you're working with piecewise function, my advice is to graph it as you would, and then erase what you don't need. You can do it that way, or you can create a chart using your X values as a guide. So let's go ahead and graph this. So I didn't include a chart. Let's give ourselves space for a chart. I think maybe 5 tick marks on each side should be enough. All right. Let's go ahead and graph this. So that first one is going to be a parabola, and I want it x is smaller than 0. But because we have a less than and not a less than or equal to, I know this will be a open circle. Open circle. All right, so if you want to, we can use a chart. So we want values that are less than 0 starting at 0. So I want values such as 0, and that they're smaller. So let's do -1. And I'm happy with that. We know it's going to be a U shape. Okay, so let's go ahead and figure this out. Let's give ourselves some space to work. And our value x, y. So we have x equals 0, so I have 0 squared is equal to 0. I have the point 0, 0. Then I want to replace it with a -1. -1 squared is +1, so I have -1, 1. All right, so I have 0, 0 here, and -1 up 1. And I know it's going to be a U-shaped figure, a parabola. So there we go. Now I want to make sure I write that 0 as an open circle because it's not a value in our answer. It's an open circle. Okay. Next one. We have our x plus 2. It says I want values that are greater than 0. So let's go ahead and do a little chart for that one. So I have x greater than 0, including 0. So I have 0, 1, and 2. Okay, so if I plug in a 0 into our function x plus 2, 0 plus 2 gives me 2, so I have 0.0, 2. If I plug in a 0, if I plug in a 1 for x, I have 1 plus 2 equals 3, 1, 3. And if I plug in a 2, 2 plus 2 equals 4, so I have 2, 4. Let's go ahead and graph that. So I have 0 up 2 with a closed circle, and 1 up 3 with a closed circle, and then 2 up 4. And we know that this is going to be a line. We know it's a line because my x is to the first power. And that continues on forever, starting at 0. And there we have it. We have our piecewise function. Now, if your argument, meaning those x values that we see, that's your argument for x. If these seem different or weird, you can just graph your function and ignore those, and then erase what it's not asking for and only include what it is asking for. All right, let's go ahead and continue with the next question. Section 1.3, problem 9. Find the average rate of change for each function on the interval specified for real numbers b and h. So this average rate of change, that's a pretty important deal. You'll see that a lot in your calculus courses, the average rate of change. And the best way I can describe it early on is that it's really your slope. It's your y2 minus your y1 over x2 minus x1. Now, the way your text describes it, and the way it is defined, what an average rate of change is, so your average rate of change is your f of x2 minus your f of x1 over x2 minus x1, which is your same thing, because isn't your y's your output? And isn't your f of x of a number your output? So you're finding the change of your outputs divided by your change of your inputs. So I always like to say, think of it as your slope. Okay, let's go through this problem and let's think of it as our slope. So we have f of x is equal to 2x squared plus 1. Now I'm going to help you think of it as a point, as a slope. So for our first one, we're saying we're going to let x equal x. So we have f of x is equal to 2x squared plus 1. And that's our answer. That's it. That's our output. If you want to write it as a point, that would be x comma 2x squared plus 1. Okay, let's do that, x plus h. So this is saying let x equal x plus h. So we're going to replace our x with all of x plus h. So I have 2 times x plus h, and my x is being squared, plus 1. Okay, so we have to go ahead and square this. You can go ahead and FOIL like we did at the very beginning. So I'm going to jump to the front page. You know how we talked about expanding a binomial? You can go ahead and multiply your first, inner, outer, and last. Or you can use one of your formulas that we mentioned. All right, looking at our current problem, I'm going to use a formula. So this gives us 2 times, and that gives me x squared plus 2xh plus h squared. So that's just the squaring of my x plus h squared, plus 1. Now I have to make sure to distribute that too. So that we have 2x squared plus 4xh plus 2h squared plus 1. Okay, so now I have my outcome, my answer. So if I want to think of it as a point, this would be my point, x plus h, comma, 2x squared plus 4xh plus 2h squared plus 1. All right, let's go ahead and find our average change of rate, or your slope. It's your slope. I have to label my points because I will make a silly mistake. So this is my point 1, this would be my x1, and this would be my y1. This is my point 2, so this would be my x2, and that would be my y2. Let's go ahead and find our slope. So I have m is equal to y2 minus y1 over x2 minus x1. Let's go ahead and input those values. So y2 is all of that. So let's go ahead and write that down. So that gives me 2x squared plus 4xh plus 2h squared plus 1 minus minus y1. What is y1? Our y1 is right there, 2x squared plus 1. Let's go ahead and write that down. 2x squared plus 1. All of that divided by my x2. This is our x2, x plus h. Minus my x1. And x1 is just your x. Okay, we set it up. This is totally half credit. You did so much work. This is important. All right, now it's just a matter of cleaning it up. So to clean it up, we want to make sure we are distributing that negative in. So that we have, continue right here, 2x squared plus, yeah, we have to write it all over again. 2x squared plus 4xh plus 2h squared plus 1 minus 2x squared minus 1, all of that divided by x plus h minus x. You write it bigger. There you go. All right, what's cool about here is that you should have things canceling out or adding to make 0. And we do, right? We have a plus 1 and a minus 1. We have 2x squared minus 2x squared. And in the bottom, I have x minus x. So what are we left with? We are left with 4xh plus 2h squared divided by h. Now we see this h is dividing both your numerator and your denominator. And yes, I did draw a heart because your h is dividing both terms. So if an h is being divided from each one, we're left with 4x plus 2h. And that is our answer. Now these problems are tedious. I always make a mistake. I'm surprised I didn't make a mistake right now. I probably did. And if I did, please tell me. Especially when we have a lot of pluses and minus, I always make the mistake of not connecting my pluses and somehow things magically turn into minuses. So be very careful with these problems. But this is your average rate of change, which is a lot like your slope formula and a lot like your difference quotient. And this, you'll see this as a main topic when you go on to calculus. So that's why you see it so much. We had two problems that looked a lot alike. All right, problem 6. Find f of g of x and g of f of x and simplify your answers. So this is composition, right? You're putting one function into another function. Let's go ahead and work this out. So I want to find f of g of x. So what this is saying is we're going to take our function g and I want to plug it in for all of x, which is just there. Okay, so this would be the cube root of, and I have to write all of my function g for x, which would be x plus 1 all over x cubed. That's it. If you did this much, you're good. Now from here, all we can do is simplify. Now for this problem, you have to rely on your rules of exponents that you might have learned back in like intermediate algebra. And this says if I have a radical applying to a fraction, I can split my radical. So I can simplify this to be the cube root of x plus 1 divided by the cube root of x cubed. And we can simplify that further so that my x cubed and my cube root and my x cubed are mathematical opposites. So that just gives me x. So my final answer would be the cube root of x plus 1 divided by x. That would be my answer for that one. For the next one, let me erase all that work up there. I'm doing the opposite. I'm taking my function g, and for every x on my function g, I'm going to plug in f of x. So let's go ahead and do that. So we're going to take my function f, and I'm going to plug it in for every x in my g. Now, when I do that for my g, I have two x's. I have an x there, and I have an x there. So we have to do it twice. All right, so we have x plus 1. Instead of x, I'm going to write my function f, which is the cube root of x, plus 1 divided by x cubed. So I have x cubed, and I'm going to write the cube root of x. And there, we did that substitution. And I think that's a tricky part. I always have to sit there, maybe highlight and think where numbers go. All right, so we notice that the cube root of that x cubed, that cubic, and that exponent are mathematical opposites, so we're left with just x. So my answer is the cube root of x plus 1 divided by x. And that's my answer. All right, great. If there are any questions, again, you can use the chat, or you can unmute yourself. All right, next question is section 1.5, problem 19. Describe how the graph of the function is a transformation of the graph of the original function. Now, transformations are not my favorite thing to teach because I feel like it takes a lot of time for what we're trying to get to. So let me give you a quick rundown of transformations. So from your transformation section, you should learn that if you have a function y equals f of x, you have shifts. If you have f of x and on the side, hanging out on the side, I think it's the best way I can describe it, just hanging out outside your function, if you have a plus or a minus, we say a number k, then it's going to move up and down. So plus k is up, minus k is down. One other major one that you see is if you have something being added or subtracted within your parentheses, your square root, your something, it's usually something enclosed. So we have f of x plus, we say minus or plus some value h, then that's a horizontal shift. If you have a minus h, it's going to be to the right. And if you have a plus h, it's going to be to the left. And I know your horizontal shifts are counterintuitive. We think plus right and minus left, but it's kind of the opposite. Another major one is compression or stretch. So we have a number multiplied to the very front of your function. That's going to give you a compression or a stretch. If a is greater than 1, like 2, 2.5, 3, 5, 10, whatever, doesn't matter if it's a fraction or a decimal or a whole number, if it's greater than 1, it's going to be a stretch. And if that number is between 1 and 0, it will be a compression. Be made to look wider. And quite honestly, that's a quick rundown of 1.5. So to do this section, to do this problem, I just want to say where the transformations are. So we see that we have these numbers. We have this plus 4. This plus 4 tells me I have a horizontal shift. Okay, now let's use the chat function of Zoom. Do you think it's going to be to the left or to the right for units? So am I going to move left, right? Yeah, thank you. Left. we're going to move left 4 units. Now for that -1, that tells me I'm going to move, it's a vertical shift down 1 unit. And all we're doing is that we are using that very general function y equals f of x, and we're trying to compare shifts. And honestly, that's the main concept of 1.5, and it's just to recognize how your functions move. All right, question 8. 1.5, problem 47. Determine whether the function is odd, even, or neither. So that refers mainly to reflection over the x-axis and your origin, type of reflections you may see. So the two rules are if you plug in a negative into your function and you not magically, but through exponents, even exponents, you get the same function back, then you say it's even. If you plug in a negative function and your answer is your same function, but with a negative factored out at the front, so you factor a negative from every term, then it's odd. Now, what's cool about this is that you take the same initial step and your answer is the one that tells you what you have. It can be even, odd, or if both fail, neither is an option. So let's take a look at this problem. We have h of x is equal to 1 over x plus 3. Let's see what we get. It's always the initial step of plugging in a negative x. So let's plug in a negative x. All right, so we have h of negative x is equal to 1 over negative x plus 3 times negative x. And be careful when you're substituting to make sure you use a negative, because otherwise you can make a silly mistake there. All right, so for our first term, all we have is negative x, negative 1 over x, right? Negative 1 over x. And then for our second term, we have 3 times negative x minus 3x. All right, so now we take a moment to pause. You want to see, is it the same? And no, our signs are different. It's not the same. Okay, so we can say it's not even for sure. We can rule that one out. Okay, let's go ahead and factor a negative. So if I factor a negative, I'm left with, so I divide each term by a negative, 1 over x plus 3. Now I want to ask myself the same question. Is it the same function, but with a negative at the right front? Yeah, in this case it is. So we can say the function is odd. And that's it. Now, if it weren't odd, then our final conclusion would be this function is neither odd nor even. It's neither. All right, almost done. I don't want to bore you. I just want to make sure you go through those big concepts that we've learned. Section 9. No, problem 9, section 1.7, problem 11. Find the inverse function. So your inverse function, you have a list of steps to follow to find the inverse. Your list of steps are 1, you want to change the function notation to y. You just want to change it back to y. Your second step is to interchange, so swap your x's and your y's. So everywhere you see an X, replace it with a Y, and vice versa. Wherever you see a Y, replace it with an X. Your third step is solve for Y. And then you have your inverse. So fourth step, last step, is replace Y with that inverse notation. And you have found your inverse. So I'll leave that on the side as we work this out. So I want to find the inverse of this function. All right, so first step, I want to change f of x with a y, so that I have y is equal to x divided by x plus 2. All right, second step, we want to swap out an x and a y, all of your x's with all of your y's and vice versa, so that we have x is equal to y divided by y plus 2. Third step, and this is the only one that requires some effort, is to solve for y. So we want to get y by itself. Now I chose this problem because it's tricky, because we have 2 copies of y. When you have 2 copies of something, you want to get them together, you want to make sure they're on the same side. But we first have to undo that fraction. So let's go ahead and divide both sides, or multiply both sides by y plus 2. So I want to multiply by y plus 2, so I can get that out of the way. And now we're left multiply on the other side too, so that we have y plus 2 times x is equal to y. All right, to undo that multiplication, I have to multiply it out. So I have to distribute the x into the parentheses. So I'm left with xy plus 2x is equal to y. Okay, now I want to factor out an x, because I want to get just what do I have? Okay, scratch what I said. Now I want to get my y's on one side. So I'm going to subtract xy to both sides, so that I have 2x is equal to xy we want the minus in the middle. So y minus xy. Okay, this is a part that made it different. Because I have 2 copies of y, I want to get y by itself, but I have 2 copies of it. So luckily we can factor. So let's go ahead and factor. So I have y. If I factor out a y, factor out a y, I'm left with 1 minus x. Cool. Now I finally have just 1 copy of my y. Now I can go ahead and divide by y minus x, 1 minus x, and I'm left with 2x over 1 minus x is equal to y. And that's our inverse. Very last piece, I want to replace that y with my inverse notation. So your inverse notation is the little exponent of -1. But when it's using an f of x for your function, we know that means inverse. So our answer is f inverse of x is equal to 2x divided by 1 minus x. And what inverse is, it's the math, you're taking an equation and you're creating the mathematical opposite of an equation. And that is an inverse. Now for problem 10, section 1.7, this is problem 41. A cool thing about inverses is that it gives us the values from our domain and our range. And since they're opposite, they create opposite domains and ranges. So if you have a function f and you have a domain projecting a range or an output of a range, for your inverse, your domain is made up of your range which will output your range that is actually the domain of your f. And that's a very special feature that only inverses have. And to be an inverse, it needs to be a one-to-one function. So it needs to pass both the vertical and horizontal line test. Okay, so now we can do problem 10. Simple question. It's asking to find the inverse. Well, if you have your domain of x and your range of f of x, then to find the inverse, we just switch our table so that we have our domain and our range. So I have one, we have our f, our x, and our f inverse of x. And then we have 5 boxes. All right, so our domain is x, and our output for our inverse is f inverse of x. And all we're gonna do is swap things around. So for x, I'm gonna write my answers, which are this bottom row. So 1, 4, 7, 12, and 16. And for my range, I'm going to use that top row. So my answers, my range would be 3, 6, 9, 13, and 14. And that's how we create an inverse function if you have the points. So to extend to that, if I were graphing a function and I know points from my function f, to find the inverse, I take those points, swap them, and plot those points, and now I have my inverse. All right, so these were key points from chapter 1. Now, before we leave, I want to give you a quick Canvas tour. Now, I'm sure you're a Canvas pro by now, but I just want to make sure we're on the same page. I want to show you your support course Canvas shell, and then answer any questions you might have afterwards. All right, so I'm going to leave this page. Okay, and I want to share my screen. So you should be seeing my Canvas shell. And for our pre-cal, for all of my classes, I start off with just an overview. We're going to be doing very plain list of what you're going to do. Now for this week, we have a quiz, but when I made this shell, I wasn't planning on getting sick. So I'll push our quiz back to the following week. Your quiz will be chapter 1 stuff. So if you are okay with everything we did on the review, then you should be in good shape. I hope to make it multiple choice, and I hope to give you 2 chances so that I try to make quizzes not too high stakes, but lower stakes, so that you treat that as a learning opportunity, so that when you turn around and do something that's worth a lot of percents on your final grade, like an exam, you know what mistakes you need to be aware of. And I think that's what quizzes are, finding out what your hiccups are. Okay, moving forward. So in your module, that you always have a home page, and then the weird thing about the home page is that a next button doesn't appear. I usually add a next button, but I guess I didn't for this week. But you can find everything in modules. And modules is a breakdown of however I broke down the class. Now I'm breaking down the class as a week by week. So you see you have all of your week 1 stuff, your week 2. If it takes up too much space, you can always collapse it. If you want to see what was there, you can always expand it. Just use that little arrow next to where I labeled as a week. All right, we're in week 4. We had a Zoom meeting, and I have information about that Zoom meeting there. And then we had some lectures. I'm thinking of removing 2.2 just because I don't want to focus too much on lines. I want to get into the more heavier concepts for college algebra. And there's a quick summary that just says, blah, 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 we did this, this, and this. And that just lets you know you're done. Then you can see an overview of everything. If you ever want to see an overview of everything, I think modules is the best way to go. And if your weeks are taking up too much space, you can always collapse them so that you only have your current week expanded, or however you want to do it. I also included this extra module where you can see a schedule of what we're going to do for the rest of the semester. And pre-cal is a very intense course because you're basically mixing two classes together. You're mixing college algebra and trigonometry. So this is what we're going to do for the semester. On that very first module, I also have a list of the homework, just so you have it in one place, and I'll add more to it. I'll scratch out 2.2. And I also have a link to our office hours. So I offer office hours Monday through Thursday. Mondays is from 5:30 to 7, and Tuesday, Thursdays is from 12 to 2. You can just press that link, and at that time, I will be there. The office hours are first come, first serve, so you'll just be in the waiting room until I get to you.
For Tuesday and Thursday, is it 12 or 1? I'm confused.
Oh, 1 to 2? What did I write?
It's because you said 12 and it says 1, so I
Oh,
kind of
okay.
threw me off.
Oh, man, okay. Yeah, office hours are from 1 to 2. I don't know why I said 12 to 2. It's from 1 to 2. Thank you for asking that. All right, so it is as it is written. I said it wrong, but the typing is correct. And I think that's it. If I have anything important to share, I make sure to write an announcement. So I think after this, I'll write an announcement saying, hey, your video is available, and I'll tell you where it is, which is in that Zoom meeting chapter 1. I'll put it there. And also say, oh, our quiz 1 is pushed to next week, and it's going to be based on chapter 1 content. And that's what I'll say there. Now, I do want to share with you, I think this is a pretty different college algebra class because when I taught this at other colleges, they teach college algebra for one course and then trigonometry for another course. But then I was seeing that at the school, we don't teach trigonometry. So I think what I'll do is I'll start introducing small trigonometry things in the support course as we go on. So maybe like from week 6 and on. Now on your support course, I haven't put much there. All I have is a couple of YouTube videos for you to check out based on what you feel is necessary that you review. So there's exponent rules, order of operations, call it PEMDAS, how to FOIL, which is what we did, expanding a binomial, which is what we reviewed today, and factoring is a whole monster of itself. If you think that factoring is not something you can see more of, feel free to check out these videos, and I'll make them available now. Everything has been closed. I need to publish them. There we go. So you can go ahead and go into that Canvas shell, into that co-requisite Math110 Canvas shell. I have those videos there. Those are not worth any credit, but next week I'll add some stuff where I'll add some things, some quizzes, very low stakes. I think I'll add like 10 opportunities. I just want you to get it. Next week, I want to review Pythagorean theorem because that's a very helpful tool for trigonometry. So I just want to make sure you're a pro at that. Though I'm sure you are. Okay, I think that's all I want to talk about. Are there any questions that you have that I can try to answer? Any homework questions? Yeah.
Sorry. For the quiz, is it timed, or can we take as much time as we need to for each?
I think I'll make it timed, but I'll make it a very long amount of time to where you should be able to do it, and I'll allow multiple attempts. I'm thinking 2, maybe 3. Let me write this down because otherwise I'll forget. So
Will we have to show work and send you pictures, or?
Not for this one. So I'm thinking of doing it multiple choice and 2 to 3 attempts per the quiz. And I'm going to make a multiple choice. There would be times where the quiz would be, here are your questions, answer them, send me the PDF. So that's why we had that week 1 assignment where you practice turning in a PDF. So not for this one. There's going to be different ways that I collect your work.
Oh, so in the future there will be some that we will have to show our work.
Yeah. Particularly your exam. So I'm thinking of having an exam 2 weeks from now. I like to make your exams part multiple choice, part open response. Multiple choice will be worth half, and your open response will be worth the other half. And the open response will be just like 3 or 4 questions that are kind of on the more challenging side, but are like important concepts for this. And that will be your open response. And for those, you'll have to upload your work and your answers as a PDF file. Okay. Are there any more questions? All right. So I guess that's it for today. If something does pop up that you might have forgot to ask during our Zoom meeting, you can always email me. And that reminds me, when you email me, please email me via Canvas, because through my regular email, not only do I get emails from you guys, which is fine, but I also get emails from the district. So it's easy to get those emails lost within all these other emails. So please email me through Canvas. It's probably the best way so that I can get to you quicker, because all of my Canvas emails are only from you, the students, and that way I can get to you quicker and you won't get lost among all those other emails that I get from other people that are not my students. So I think that's the best way to go about it. But if you do email me outside of Canvas, I see it, but it might get lost. So, and also, if I ever don't respond to an email, please don't take it personally. Just send me another email the next day if I didn't respond. It's easy to I don't know, walk away from the computer and forget I was reading your email. I don't know. Just don't take it personally. Send me another email. You're not bothering me at all. I am happy to help you. I know as an instructor, I'm one of your biggest resources. So ask me, I'll be happy to help. All right, now if there aren't any more questions, I'm okay with us signing off. All right, so this was our Chapter 1 review. Have a wonderful weekend, and I'll be looking forward to your questions if you have any.
Bye.
Bye-bye.
Okay, thank
Bye.
you. Bye.
Bye.
Thank
Goodbye.
you.